Hello, everyone. We'll be starting with the session now. Hello, everyone. Good morning, good afternoon, good evening. Dear authors and invited guests, welcome to the technical session 7C. Myself, Anshika Jain, and this session would be moderated by me. I, on the behalf of Global Knowledge Research Foundations and GR Scholastic LLP, it is my great pleasure to welcome you all to the 4th World Conference on Information Systems for Business Management ISBM 2025, Bangkok, Thailand. The fourth edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Bangkok, Thailand, and the virtual event is being held through Zoom today and yesterday, that is 25th and 26th September 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. Before starting this session, in this session, we will have 10 presentations and each presenter will be given 10 minutes for the presentations and 2 minutes for the questions and answers. On 9 minutes, I will raise a very gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any queries or any updates, that you can write it to me in the chat box below. Just before we get started with the session, I would like to introduce you all to the chair for the session. First, we have Professor Adolfo, faculty at National University, Manila, Philippines. Welcome to the session, sir. Would you like to share a quick opening remark with us?
Yes, good morning, everyone. I am Professor Adolfo R. Arevalo, and it is my pleasure to welcome you all to this session in Virtual Room 7C, Virtual Room C, starting at this very time, 9:30 a.m. in Bangkok. And I am joined by my co-chair, Professor Sharif Fatan. And today we have a very exciting lineup of research presentation that cover a diverse range of topics, from financial technology adoption and artificial intelligence to supply chain innovation, healthcare applications, and advanced deep learning models. Allow me to introduce the sequence of paper that will be presented in this session. The first, a study on the adoption of UPI applications in Kerala among Generation X by Samanarayan Napambra SS. Second is the accelerating AI agent development through a domain-specific programming language by Salvatore Villa. And third, we have adopting smart tools in the mango supply chain for enhancing circular supply chain by Brian Atunga. Fourth, we have the unattention-based deep learning framework for gold price prediction using time series data by Pondro Chandra Shakir Reddy. And we also have Arogya Mind NER, benchmarking a mental health NER data set for Marathi by Paula Antipatil. And the sixth is the design of e-learning system for college students by Nabeen Bardia. Seventh, we have enhancing full stack application development with generative AI-powered conversational user interfaces by Mohit Minghani. We also have Ensemble Deep Learning Framework for pneumonia detection in chest X-ray using the RSNA database by Anari Panja. We also have From Algorithm to Assurance, understanding the link between AI-based personalization and consumer trust in beauty products by Zana E. Santos. And the last is Towards Bioacoustic Insect Recognition, Spectrotemporal Attention Networks for Fine-Grained Insect Classification by Nandini Nayakudi. So we look forward to insightful discussions, new perspective, and fruitful exchanges from this session. On behalf of the organizer, I thank all the presenters and participants for joining us. So let us now begin with our first paper.
Yes, thank you so much, sir. I would also like to introduce everyone to our session chair, Dr. Shafi Pathan. Sir is a principal at Anjanam I Islam's Amit Sahu Siddiqui College of Engineering, Mumbai. With 24 years of academic experience, he has authored 5 books, contributed a book chapter, and presented 39 research papers in national and international journals and conferences. His research interests includes ML, deep learning, Internet of Things, network and information security. Welcome to the session, sir. Would you like to share a quick opening remark with us?
Yes. Good morning, Anshika,
Good
Ariba,
morning.
and Dharmik, Salsar, Sini. Uh, First of all, I should thank you, GR Foundation, because they have given opportunity to all of us to come on one platform. Again, thank you to Dr. Amit Joshi, Dr. Prakshit Mahalle, Dr. Nilanjan Dey, and my own colleague, Dr. Prashant Dhotre. As far as technology is concerned, we all know that technology disruption is coming in a huge way. Things are changing so fast. Yesterday there was a Java, C, uh, as far as technology is concerned, and then there was the concept of data structure, algorithm, operating system, and all these things. And today everybody is talking about AI, artificial intelligence, cyber security, and all these things. Conferences are the only places where all these coming technology and trends are discussed. It gives an opportunity to interact with you, understand the things which are going in the market, which are going in the universe, and if and in other way, how as an individual we can contribute to the system so that we can make a complete system in a way which will be helpful to the industry as well as the humanity. So thanks once again. I'm very happy. I'm very excited about to listen all the technology and trends or research which is going in the around the globe. So I wish you all the best to all the participants, and once again thank you to GR Foundation.
Thank you so much, sir. So we'll be moving on with our first presentation. First, we have Saimana Rayana Prabha SS to present his paper title, A Study on the Adoption of UPI Applications in Kerala Among Generation X. Are you there? Are you there? Okay. So we'll be moving on to the next presentation. Next, we have Salvatore to present the paper title, Accelerating AI Agent Development Through a Domain-Specific Programming Language. Are you there?
I am, yes. Thank you.
Yeah, you may please begin with your presentation.
Thank you very much. Can you see me? Can you see the presentation?
Yeah, I can see your presentation. You may start.
Awesome. Thank you. Thank you for good morning, and thank you for joining today. I'll be presenting our paper, Accelerating AI Agent Development Through a Domain-Specific Programming Language. My name is Salvatore Vella, and from Toronto Metropolitan University in Toronto, Canada. Who we are, 5 of us here. We have a mix of business experience and academic. I'm a longtime, twice retired technology executive, both at IBM and at Royal Bank of Canada, where I led technology strategy and technology innovation, and currently a doctoral student at Toronto Metropolitan University. Fatima and Salah are both technology executives at RBC as well. So a nice mixture of academic and business experience. The agenda here for what I'll cover fairly basic. I'll cover the goal for the work, a little bit on the abstract, what it is. I'll focus on the content creator orchestration language, the language that we've created for this. I'll give you a set of examples that use it and talk a little bit about future work. So the goal is pretty simple. It's maybe too many words here. How might we create a simple, easy to use programming language to enable the creation of deterministic business workflows that use generative AI? What we wanted to do was a language that was simple, easy to use, and able to be used by non-programmers. Also, we wanted to be able to, when you execute a business process, there's a certain set of steps that need to be executed. person A may do one step that feeds to the next, that feeds to the next person, a review, and so on, but in a deterministic way. And we wanted to be able to represent that. And obviously, it's about the generative AI. The abstract is here. We know that Gen AI is helping knowledge worker tasks, creating communication, summarizing documents, lots there. But we want to be able to execute business workflows in a predetermined way and automate those. And we see that as, and I'll show you in a bit, that we see that, I see that in a way, an analogy to programming languages, going from assembly language to high-level languages. So this is the picture I like to use. And when I started programming, I was programming in machine language and assembly language. And for those who don't know, those are very small sets. So set a register, move a register to another register, very atomic operations. And then came the advent of high-level languages. So COBOL for business, Fortran for technology world or technical tasks. And then came C, Pascal, and many others. So all of those, what they mean is abstraction from the hardware, from the bits, to be able to do specialized tasks. So speed and efficiency is what you get as a result. Similarly, on the Gen AI world, we've had ChatGPT, and you can also call any of a number of LLMs one by one in an atomic way. I would say that's like a single atomic step, like assembly language, and then there were frameworks. LangChain is one that lets you do higher level tasks, but lots of programming required. And there were several academic studies, ChatDev to mimic a software development team, AI scientists for research. And what we see is the emergence of languages to be able to do these business tasks. And I'll show you what those look like in a number of examples. So I think I've talked about most of these. One of the things that I do want to mention is that this work is part of a larger piece of work to create full agents. So agents that have knowledge, experience, and can learn over time. And so this is a way to be able to orchestrate those agents. Simple to use, and we want to be able to solve at least some are simple, some are not so simple problems with this language. So strategy development, I'll show you those examples as we go. Languages here, we have a BNF for it, lots of different verbs to be able to execute, and some number of control statements as well. Now, I'll get into the fun stuff, right? What does this mean? And so here's a simple hello world. Every language has a hello world, a very, very simple example. And in this case, we have two inputs. We have a standards document for robots that specify safety procedures for robots, and a description of a specific robot. Those are given to an agent that's acting as Stephen King and asked to provide story ideas for books. So Stephen King is a horror writer, for example, in this case. And the code is on the left-hand side. You see how easy it is to be able to inspect the document, ask the document specific content from it, be able to integrate that with a robot description, and then give it to an agent, in this case, Stephen King, with some instructions to act on it. And as inputs is the outputs from the previous steps. And you can see on the right-hand side, it actually does some interesting work where it integrates the two pieces of knowledge. It does, interpreting dirt as the presence of humans is in reference to the cleaning robot, and no proactive emergency stop measures is really one of the issues or one of the safety aspects that has to be there in a robot in the ISO document. So it uses those reference documents to create what the output. This one is interesting. I spent a few years with Royal Bank of Canada, and I had responsibility for technology strategy. And so we would build a technology strategy much this way. And actually, I ended up sharing the results of this with my old team. And they were impressed and a little scared of how good a job it did. So the way that strategy development works is the CEO and the CIO provide, the chief executive officer, chief information officer provide their perspective about business goals and technology goals. That's handed to an internal strategy consultant who then works with both internal stakeholders and may go outside to, economists, consultants, a McKinsey consultant, Gartner, others. There's a legal review, a lawyer involved, and then that gets synthesized, reviewed, synthesized, summarized, and passed on. And we can represent that workflow on the right-hand side here. And you see that the language is very good for being able to specify inputs from a previous step, acting on it with an agent acting on it, and then having outputs that can be consumed by steps further on. So in this case, the CEO and CIO provide their inputs. That goes to an internal banking consultant to create the first draft. Then there's a set of reviews from the economist, the McKinsey consultant, the lawyer, and then the internal banking consultant integrates all that information, in this case, sends it to the communication specialist to summarize and has it released. So very nice, compact way to be able to represent these flows. Another example here is a policy reviewer. So in this case, there are policies, let's say a conflict of interest policy that has best practices. And so in this scenario, there's a policy reviewer that reviews the policy based on the best practices, and a policy updater that, once the issues are identified, updates the policy with fixes the issues here, right? And again, a few lines of the code here replaces what would be many lines of a Python code, for example, to be able to specify this, or cutting and pasting from multiple ChatGPT screens if you wanted to do that. So here the policy reviewer reviews the policy, finds the issues, gets a list of issues, and then for every issue works to go ahead and fix the policy. And again, this can be run several times as well if there's issues. There was a paper on an AI researcher. The team built an AI.
Hi, sorry to
res-
interrupt you, but you have
Yeah.
1 minute to conclude your presentation.
Okay, then I will go here. Future work, there's lots of examples. One was an academic researcher, a second was the software development team. Next steps, which we're already working on, one is embedding into programming languages, much like embedded SQL. We're doing that. The other piece is hardening human and interactions and feedback into the language, because we want to be able to have some steps done by AI, some steps done by humans, and then the benchmarks of this system. And so with that, I will conclude and open it up for any questions.
Thank you so much for your presentation. Sir, do you have any questions for the session chairs?
Hi, Sam.
Hi.
Can you give some examples where local level programming language, you have given the example of assembly level language programming and machine levels to some extent. Are there any examples where local language level contributed to the AI development?
Well, I think that the one thing that it is, because it's control flow, right? And so the piece that now I grew up in the database world, building databases, right? And so there's a concept of embedded SQL. So the language is for control flow, you use Python, C, or Java, whatever your high-level language is. But for SQL, you use embedded SQL, the specific domain language. And so we've built this so that you can use one of these sets of control blocks within your Python, for example. So yes, absolutely, absolutely.
What is the support system available in the system? What is the support it is required, which is available in the different operating system? Have you came across like this? Maybe Windows, maybe Linux, maybe.
No, it's written in Python, right? So there's no real requirements for that, and the large language model backend is configurable. So again, that's also very flexible because you may want some queries done by a very expensive model, others done by a local model, for example. So that flexibility is there.
Okay, it is all from my end. Wish you all good luck, sir. Happy researching.
Thank you very much.
Uh, can I ask question?
Yes, sir. Please move
Okay,
on.
thank you. Um, uh, Professor Villa, you highlighted the efficiency of the main specific programming language. What challenges do you foresee in making such languages widely adopted in the developer community?
I think we're not yet there, right? I think we have today. Programming LLMs is really you need programming skills, and so that's a big bar. We're not quite there yet to be able. I see it because I share the language and people can make use of it, but the adoption to the business where they can begin to get more benefit than just using ChatGPT, right? One at a time and cutting and pasting. The fact you can automate these workflows yourself. So I think it's a matter of time before that happens, right? I think right now we're fixated on just the machine level and an LLM. And my thought is that it doesn't really matter. What matters is consumption of that technology by the masses, right? Yeah.
Thank you.
Thank you,
You're
sir.
welcome.
So we'll be moving on to the next presentation. Next, we have Brian to present the paper title Adopting Smart Tools in the Mango Legal Supply Chain for Enhancing the Circular Supply Chain. Are you there, Brian? Okay. So next we have Pundru to present the paper title An Attention-Based Deep Learning Framework for Gold Price Prediction Using Time Series Data. Are you there? Next, we have Pooja Anil Patil to present the paper title Arogya Mind, NER, Benchmarking a Mental Health NER Dataset for Marathi. Are you there?
Yes, hello.
Yeah, you may
Good
please begin
morning,
with.
everyone. Yes. Can you see my screen?
Yes, I can see your screen. You may start now.
Okay. Hello, everyone. I am Pooja and I am here to present the topic Arogya Mind NER Benchmarking a Mental Health NER Dataset for Marathi Language. So, I have done this project under guidance of Yashodhara Haribhakta and I am from COEP Technological University. So, these are the points which I am going to cover in this presentation. So, mental health in India is very underrated due to its stigma and lack of knowledge. So, I have decided to work on the Marathi language as very less work is done in the LLM for the Marathi language. So, NER is the topic in which I am going to extract the named entity from the mental health Marathi sentences. So, named entities are the entities for which we have the tags like it is a disease, it is symptom, or it is a treatment. So while doing this work I have faced some challenges that very less resources are available for the Indic languages. So and their NER data sets for the Marathi language were not available, and like there are very much LLM models, but these models do not work very perfectly on the Marathi language, especially in the mental health. So I have decided. So this is the research graph in which I have found out that lack of domain-specific NER dataset for the Marathi language. Existing NER work focuses on NER. There is NER work uh, uh, done on the Marathi language, but these work mainly focus on generic entities, and they are not focusing on the psychiatric terminology. So objectives of this project was to develop an Arogya Mind NER which will focus on Marathi language, and mainly it will focus on mental health as a domain. So for this, I have benchmarked this data set on multiple machine learning, deep learning, and LLM models. I have the targeted entities on which I have worked are disease, symptom, and the treatment. And the diseases on which I have worked are anxiety, depression, bipolar disorder, post traumatic stress disorder, and schizophrenia. In Marathi, we can call them as Chinta, Nirasha, Dvidruviya Vikar, uh, Aghadhanantarcha Tana, and schizophrenia will be Dvidruviya Vikar. So these are the diseases on which I have focused in this data set. While creating dataset, I have selected the data source from different Marathi articles, news articles, and the Wikipedia. Once I have collected the data, I have specifically filtered out sentences which will focus on the mental health only. After getting the data set, I have used the BOI tagging, which will be BOI here significance, B for the beginning, I for intermediate, and O for the other tag. So this tag will help me to capture the data um, from the multi-word expressions. So here you can see the example. Chinteche, ye chinteche is tagged as B disease. Bhavna is tagged as I disease. Because this is a two-word disease, so I have used B at the starting, I at the intermediate, and O will represent the author. So these in my data set, I have total 500 sentences. Out of this, I have categorized it as a train test and validation data set. And the analytics for the each entity is shown in the table. These are some models on which I have benchmarked my data set. So these are the performance matrices for the different machine learning, deep learning models. Uh, these These are the matrices for the LLM models. Here I have trained multiple different LLM models on my data set, and this is the performance matrix. From this benchmark of performance matrices, I can see that LLM perform best on informal text. Out of that, L3 Cube Marathi Social NER works the best. CNN achieves the highest accuracy among the deep learning models, and classical machine learning models underperform due to their understanding in the context. So my contributions are, I have created, this is the first domain specific Marathi mental health NER dataset. I have done benchmarking across classical machine learning models and deep learning models and transformer based models. This provides the foundation for the clinical and social media text analysis. We can use it for knowledge graph generation and relation extraction between the entities as well. So these are the applications of my data set. We can use it in the chatbot. We can use it for the clinical decision making. We can use it for knowledge graph generation and semantic search. We can use it in the public health analytics and policy making tools as well. In the future, I have decided to expand this data set on multiple entities and different languages as well. Right now, I have focused on 3 entities only and 5 diseases. So I will expand this. And I am going to integrate this data set with relation extraction. So in relation, I can focus on treats, causes, and multiple relation between the entities. I have decided to improve the recall of symptoms and treatment in the detection. So these are the some references through which I have gone through while doing the research. So any questions?
Thank you so much for your presentation, Pooja. So, do
Yeah.
you have any questions for the session chairs?
Hello, Pooja.
Hello.
Are you able to listen me?
Yes, yes.
Acha. Pooja, nice work. Because localization in the research is always promoted and it is always advised, because that gives, that we will, in that case, we are really marching toward the problem solving.
Yes.
So good work.
Yeah.
You are
Thank
saying
you.
about data set. Have you published the data set somewhere or on some standard?
Actually, I have right now I have stored it in a GitHub. So I have decided me and my professor has decided to publish it, but yet it is in process.
So who is your professor?
Haribhakta ma'am.
Haribhakta.
Yeah.
Acha, where you are planning to publish it, data set?
It is not decided.
Acha, fine. Can you tell me what, parametric wise, can you tell me one or two important parameters which you have decided as a decision making parameter?
So in the decision making, we have the entities, so like disease, symptom, and treatment. These are the main parameters on which we are going to decide it.
Acha, fine. Okay, good work, Pooja. Wish you all the best
Yeah.
and happy researching.
Yeah. Thank you.
Okay, I also have a question.
Yes.
So, how do you see your data set being integrated into real-world mental health support systems? And what ethical considerations should be taken into account?
So this is the first mental health data set in Marathi language. So we can integrate it in the tokenizer. One of my friend has created his custom tokenizer. We can integrate this data set into that customizer. We can train it and we can use it in any LLM models which are NER based.
Thank you.
Yeah.
Thank you so much.
Yeah. Thank you.
Moving on to the next presentation. Next, we have Naveen to present the paper titled Design of E-Learning System for College Student. Are you there? So next, we have Mohit to present the paper titled Enhancing Full Stack Application Development with Generative AI Powered Conversational User Interfaces. Are you there, Mohit?
Yes. Hi, everyone. Can you hear me?
Yeah, we can hear you. You may please begin with your presentation.
Okay. Let me share my screen. Do you guys see my slide?
Yeah, I can.
Awesome. Good morning, good afternoon, and good evening to wherever you guys are. My name is Mohit. I'm currently based out of San Francisco, and I'm a staff engineer with this company called Twilio. I don't know how many of you guys have heard about it, but my role there is I'm a tech lead for one of their core full stack applications in phone numbers. And with all the AI buzz, I thought the time is right to play with some of the Gen AI stuff on our conversational user interfaces, chats, and see how does it differ from traditional chatbots, and how we can overall utilize full stack app development for with the growing Gen AI stuff. And I'll also share some of my findings from what I've learned from the career, as well as from this project and involving Gen AI. So quickly going through the agenda, abstract introduction, I'll quickly go through some of the literature I referred. What did I do in this project? What was the data flow? Then I'll follow it up with the results and conclusion and future work. So going, just diving into the abstract real quick. So some of the challenges have been obviously development teams have become fairly expensive now. Skilled developers in your stack might not be readily available. But again, with the adoption of AI in this, things become pretty quick. Again, GenAI makes things very, very lightweight for setting up a lot of these full stack apps. And along with that, there is a lot of transformative potential. Just as our colleague previously shared, with all the different languages, you might need 5 translators if you want to support 5 languages, but with GenAI, you can do these things fairly quickly. Also, specifically for the healthcare industry, it brings a lot of new unrealized use cases from before, where you can stretch out your product across multiple demographics. In my current system, it's a typical full stack. You have front end, you have back end, but then what do we do is that we have a Google GenAI engine, which basically can utilize the inputs from the backend to generate custom responses. Again, and I'll also talk a little bit about how continuous development and repeated testing to get the accuracy of your results up to the mark can improve system, as well as how we can optimize performance as well. The security and accessibility, I typically just use the JWT auth token and HTTPS. That was not the focus of this research as per se, so I just let it be. And quickly, I'll talk a lot more about it towards the end, but the AI-powered chatbots have much more flexibility, and they are able to understand complex data sets fairly quickly to give us more wider set of or more accurate medical suggestions. So I'll be talking a little bit about that. In full stack, I have Node.js and Express.js, pretty typical stack. Then I have, instead of having static UIs, I'm saying that we're going to use AI-powered conversational user interfaces, which basically is GenAI along with LLMs. In this project itself, what I've done is that I built a healthcare assistant system, which is basically using Google's AI with any full stack framework that you have to get the real-time symptom analysis. Again, security is, I already talked about it. Prompt engineering basically brings more relevant and accurate AI-generated responses. Yeah, I also did some comparison with ChatGPT, and this came along with the thought of that overall what's going to happen in the next sometime. I don't want to say years or months because everything is changing so quickly, but LLMs would become very transactional, and that is where like the GenAI core engine stays the same, but you can replace LLM. You can. I hope we are at a point where you can basically deploy in-house LLMs or train our own engines to be able to return responses. Some of the research I referred to, there was one which was basically on integrated and multimodal AI chatbot assistant. Then there was a paper from Nazareth on mental health chatbot. Then I also looked at some of LLM performance stuff. Then full stack e-commerce platforms, and I also looked at a paper on healthcare information delivery. Again, a lot of wide variety, but overall the theme stayed more or less the same, where you have LLMs trying to understand how we can make LLMs more effective, more scalable, while reducing or maintaining the cost, and also how we can use some of these for improving user experience and improving performance benchmarks. Cool. So quickly going over the work. So we have a user, and the user basically enters some systems. Like I have a sore throat, I have a runny nose, which goes through my React front end. And then what this, in a typical full stack app, also what it will do is that it will create an API request. It will call the Node.js backend with Express, and this is where the fun starts. So typically what would happen is that in traditional bots, what you would have done is that you would have a huge data set of, it could be a document database or a column database. But what you're doing is that you have some key sets against which you are running these symptoms. But now what we are doing is that we have a Google GenAI model or any GenAI model for say, where you can pass these symptoms. And then this system is constantly evolving. So this system, let's say if suddenly this week we had a really high number of COVID cases, right? So we can train our model to understand the symptoms for COVID and give our users more predictive or more context-aware result on this potentially can be COVID or this potentially cannot be COVID. Traditionally, chatbots will not have this information. Traditionally, doctors will be they will be like really busy. They cannot attend so many people. So the healthcare part of it will be fairly thin stretched. But with Gen AI, we can add these more time construct data and then keep building on it. And then if you add like things like geography or like in a given city or a county, you have like sudden exposure of these results, then you have a more data supporting ability to take decisions. So going ahead with the Google Gen AI model, you can, so you process the symptoms, you generate a response, you send it back to your Node.js layer. And then again, this Node.js layer will basically pass it to the front end. And through this, we can show the AI suggestion to the user. Again, this is how a typical app would look. You have basically the website, and on top of that, you have a chatbot. In this, I was basically saying that if you ask for fever, then you can basically have a more structured follow-up, which is more relevant to fever, and then more human-like context-aware interaction. Then quickly also wanted to show the difference between different models. In this case, I just used ChatGPT and Gemini. The good thing is that all of them were fairly good in terms of relatively being in the ballpark of accuracy. But where the major difference was that if I look only at English, ChatGPT took much longer time than like a Gemini. And the reason I feel is that Google, the system or the Google infrastructure is set up in a way that it's already able to support multiple languages. Whereas ChatGPT in the OpenAI is still a fairly naive company in the initial stages of things. The context of different languages is not available. And this is where I think local players have an upper hand. Like somebody from India, if they build an LLM which is more context aware for Hindi, might do much better than like the likes of OpenAI, purely on the basis of how much context they can get on that particular language. Yeah, so we can see that the response time for ChatGPT was pretty high. Now, another thing you can like do is that you can also make it more controlled. So in this case, let's say you ask something like how to learn coding, right? Now you are on a healthcare website, you want to keep your data set or your LLM fairly controlled. You don't want to give them, data which might come under the radar of regulatory compliance or any of these things. So you can just be like, hey, I'm only focused on health-related questions. I cannot support this. And then I did a typo here. It's basically traditional chatbots. So, but this is some of the comparison I already talked about. I talked about multi-language support, providing suggestion in multiple languages, but typically you would have like a more language, like a language-specific answers. Again,
Sorry to
user
interrupt
personalization
you.
becomes,
Sorry to interrupt you,
Yeah.
but you have 1 minute to conclude your presentation.
yes. Yeah, so again, limited API integration abilities are limited to predefined rules that we have set. And again, relies on a rigid system-based logic, which is basically you are just doing text processing based on the keys you have in your database. Yeah, this is some of the response times. So I did ChatGPT, Gemini, and combined sequential and parallel execution more along the lines of distributed systems, how the CPU usage and memory usage varies. To quickly wrap it up again, I think typical full stack with ChatGPT, Gemini, Anthropic, Cloud, you can use whatever. For a healthcare specific system, it improves our diagnostic accuracy and also improves the user experience and engagement. Some of the challenges are, data bias, or where is the data coming from? Like, let's say in US, the company for this thing is CDC, right? So who all do they want to expose their LLM, or who do they want their databases to be exposed to? Also becomes a little tricky. So what is a certified medical database integration? What will be the future work if I had to really take this commercial? Would be basically adding voice and multilingual support, and future integration with more federated learning to improve our more specific fields of knowledge. Like, for example, if you want to go more deep into some cardiac health related questions, is the bot getting hallucinated, or is it still being fairly accurate? Yeah, and then the last but not the least, the major part of it is how can we get involved with people who are more medically aware, or who can validate some of this data, which will be medical professionals to make sure they are clinically relevant. Cool. Yeah, that's all I had for me. I'm open to any questions. Thank you for your time. I really appreciate it.
Thank you so much for your presentation, both the session chairs. Do you have any questions, sir?
I
Hi,
just want
Mohit.
to.
Hi, yes,
Yes.
Adiba, please go ahead. Yes.
Okay, thank you. I just want to ask about what risk or limitations do you see when using generative AI in conversational interfaces, especially in terms of accuracy and potential biases?
Yeah, so again, I think the question scope is pretty big, but some of the things that I feel are we have certain industries where the Gen AI responses need to be very regulated, healthcare being one, finance being another, security being another. The two things that I see is that one is keeping them regulated, but at the same time also making sure that our systems are smart enough, or basically like when hacking was a big thing in early 2000s, we used a term called ethical hacking. What I see now is that we need to very clearly define the ethical use of Gen AI versus just using it. So it's a great technology, but we also need to be mindful of the repercussions if people, let's say, look at a health bot and they have symptoms of, like maybe a cardiac situation, but the Gen AI tells them, hey, you're fine, just go to sleep.
Mm.
That might not be the right thing to do at that time.
Thank you.
Hi, Mohit.
Hi.
Can you share your presentation once again? Go to the architecture diagram. Now here, user is giving information. Fine. He is entering symptoms. So for symptoms, there is inbox, there is input. What about
Yes.
output? Output. Enter symptoms, where output of these enter symptoms go, and it is as of now, it doesn't reflect it in the data flow diagram.
Oh, it's basically so from the so it goes through React to the to my
That
API
is
layer.
fine. That you are saying, but diagrammatically it doesn't represent show. Only input box to enter symptoms is there. Output box, output arrow is not there to.
Oh, I actually made it like this. So this is the output.
This is the final output. I am saying about only box of enter symptoms box. Enter symptoms function. User, then enter symptoms is there, isn't it? Are you able to see here?
Yes, this one.
Input arrow is there.
Yes.
Output arrow should be there. Otherwise, it will be halted. Data will be halted there.
Oh, so basically this arrow, what I meant here was that I was showing that this basically data is flowing to React frontend, and what data is flowing is the enter symptoms data.
Actually, so input from that enter symptom should be there somewhere, right? Likewise,
Yes.
changes.
That goes through my React layer. It goes through the
That is fine.
API.
That is fine. That is fine. That is fine.
Yeah.
And at the end, you have done the comparison, Gemini and ChatGPT, isn't it?
Yes.
So for that, what was the input, or
Oh, this one, how to avoid a heart attack.
also how to avoid a heart attack? Only if you are giving based upon that only comparison is done.
Yes.
Achha,
So it
fine.
basically is, yeah. And then basically you check on like the different pieces. Like we have multiple data. Like so I was using I can check on the library that I was using, but it wasn't GitHub. It's basically an open source which basically has different parameters for measuring accuracy.
Yeah, that is fine. But for English, it is showing a huge difference between these two. And for a Hindi language, more or less both perform same. What is
Yes, because I think the Google's Gen AI is more suited to non-English languages because it has context from Google Translate.
If that is the case, then in second diagram for Hindi, the difference should be large instead of English. But difference in the Hindi language, for Hindi, difference is very small, while for English, difference is large.
I see, you mean this.
No, left one, left. First, vertical bar. First two vertical bar. If you are saying local language support for
Oh, I
Hindi,
see, I see.
Hindi
I
is good.
see.
Either you might have changed the title or there is some.
Yeah, I'll take a look at it. I think
Achha. Okay, fine, good, no issue. Mohit, but good research. Definitely, it will help as a whole in for generative AI. So it is all from my end, and I wish good luck to Mohit.
Thank you so much. Have a good day, everyone.
Thank you so much, everyone. We'll be moving on
Bye.
to the next presentation. Next, we have Aneri to present the paper title Ensemble Deep Learning Framework for Pneumonia Detection in Chest X-rays using RSNA Dataset. Are you there, Aneri? Okay. Next, we have Sana to present the paper title From Algorithms to Assurance Understanding the Link Between AI Based Personalization and Consumer Trust in Beauty Products. Are you there, Sana?
Yes, ma'am.
Yeah, you may please begin with your presentation.
Yes, ma'am. Ma'am, the screen is visible?
Yeah, the screen is visible. You may please
Oh.
start now.
Good morning, everybody. The name of my paper is From Algorithms to Assurance, AI Personalization and Consumer Trust in Cosmetics Industry. The study is basically about how AI-driven personalization influences customer trust, satisfaction, and loyalty in the cosmetics industry. The cosmetics industry is rapidly adopting AI, like virtual try-ons, skincare analysis, and product recommendations. But technology alone is not enough. So consumer trust is also a central issue. The research explores how AI can both enhance and challenge trust. Why trust matters. Cosmetics directly affect appearance and self confidence. Customers trust AI only if it is accurate, transparent, and respects the customer's privacy. Without trust, even advanced AI systems will fail in adoption. Research aim and method. The aim of this research is to study the link between AI personalization and customer trust. The method used is we have surveyed 300 cosmetic consumers who had used AI tools. Analysis is correlation, regression, factor analysis, which is used to find relationships. The key findings are customization is the strongest driver of trust, where we have got beta as 0.42, accuracy as 0.35, transparency as 0.28, which are also significant. Together, these AI features explain 65% of variation in trust. So survey reliability was strong, where Conchback alpha is 0.85. Implications. Brands must balance personalization with privacy. They have to ensure accuracy and inclusivity. That is to avoid bias in skin tone and preferences. They have to use explainable AI so that customers can understand recommendations. They have to combine AI plus human expertise for credibility. Conclusion. AI personalization improves trust, loyalty, and satisfaction. Success depends on accuracy, transparency, and strong data security. Brands that adopt ethical AI practices will build long-term trust. Thank you.
Thank you so much for your presentation. So, do you have any questions?
Hi, Sana.
Hi, sir.
You say that explainable AI will be helpful for the parameters, especially, isn't it?
Yes, sir. Yes, sir.
Can you give me the example, any live or any practical example of it?
Yes, sir. So basically, explainable AI means AI that clearly explains why it made a recommendation, making it more transparent and trustworthy. For example, a line is, this skincare product was chosen based on your skin type and past purchase.
Acha.
Yes.
And what was your motivation for going in a cosmetic or in a skincare product?
Sorry, sir.
What was your motivation
Oh.
behind choosing this domain?
So cosmetics are highly personal and tied up to self-image. Like I personally chose it like unlike other industries, trust plays a huge role here. If recommendations are wrong or biased, they impact the customer's confidence and also the brand perception that makes it cosmetics a unique and sensitive context to study trust in AI.
It is all from my end. Sana, wish you all the best.
Okay, so thank you.
I also have question.
Okay, sir.
Um, do you think there is a point where too much personalization might actually reduce consumer trust? For example, if a customer feel like their data is overused.
So I did not understand.
I mean, okay, I will repeat. Um, do you believe that there is a point where too much personalization might actually reduce consumer trust? For example, if customers feel like their data is overused.
Yes, sir. Like I said, in cosmetic industry, trust is very important and also privacy. Personalization requires data, which raises privacy concerns. Brands must, that's why, balance both privacy and personalization, which is necessary, and it also increases their brand perception among customers. Which ensures they have to ensure that they don't leak data, or like they have to ensure that there is a consent of customer before they use any of the data, and this they should ensure basically transparency among the customers.
Thank you.
Yes, sir. Thank you.
Thank you so much for your presentation. We'll be moving on to the next presentation now. Next, we have Nandini to present the paper titled Towards Bioacoustic Insect Recognition Spectrotemporal Attention Networks for Fine-Grained Insect Classification. Are you there, Nandini?
Yes, ma'am.
Yeah, you may please start with your presentation.
Can you see the screen?
Just wait for a moment. Yeah, I can see your screen now. You may please begin.
Yeah. Good morning, everyone. I'm Nandini Naikudi. I'm excited to present our work on Towards Bioacoustic Insect Recognition Spectrotemporal Attention Networks for Fine-Grained Insect Classification. So this research was conducted in collaboration with Amarnath at Amrita School of Computing under the guidance of
Nandini, your voice is breaking part.
I'm going to keep this presentation very simple and focus on the key insights from our work.
Nandini, we cannot hear
Let me
you.
start by highlighting the agriculture challenge we're addressing. Traditional pest monitoring in agriculture is plagued
Nandini,
by
your voice is breaking. Is there any internet issue from your end?
Hello,
Yeah. We can hear you clearly now. Your voice was breaking in between.
is it clear now?
Yeah, it is clear now.
Hello.
Hello, yeah.
Hello.
Yes, we
Ma'am,
can hear
can
you.
you hear me now?
Yeah, your voice is breaking a little, but we can hear you. You may please continue.
Hello.
Hello. Yeah, Nandini, you can continue
Hello.
now.
Can you hear me now?
Yeah, I can hear you. Your voice is breaking a little. You can, continue.
Hello.
Yeah, you can continue now.
The thing is, there are heavy rainfall. Yeah. The thing is, we're experiencing heavy monsoon rains here in Hyderabad. I'm sorry. Is it clear now? Yeah.
Voice is
Should
still
I continue?
breaking. Yeah, you can continue now, but try to make it clear, okay?
Yes. Coming to traditional, yeah. Now coming to the traditional pest monitoring in agriculture, manual scouting is extremely labor intensive and time. Yeah, manual scouting is extremely labor intensive and time consuming. So visual inspection are prone to human error and have heavily influenced by encounters like lightning and weather conditions. Most critically, these methods lead to delayed responses to pest outbreaks. So, our solution leverage bioaccelerators, specifically the wingbeat sounds that insects generate during flight. These signatures encode specific species frequencies and harmonic patterns, acting as a natural biomarkers for identification. Our approach enables automated, non-invasive with high accuracy. For this study, we curated a focus subset from insect curated thousand data which controlled using 4-channel microphone arrays. Our agriculture focus led to select 3 critical species. Each class contains approximately 5,000 audio samples recorded kilohertz with 32-bit resolution. The key challenge is find species while ensuring we can reliably identify beneficial pollinators. So, our methodology consists of a comprehensive pre-processing pipeline and a novel neural architecture. The pre-processing begins with 4-channel audio input, which we filter using a Butterworth bandpass filter centered at 1050 Hz to isolate flight tone frequencies. We then perform windowing and segmentation with 50% overlap, discarding low energy segments to remove silence and noise. The key innovation in our pre-processing is the use of PCN, per channel energy normalization, which enables log-mill spectrograms by improving contrast and noise robustness. PCL provides sharper transition and uh, harmonic log-mill. uh, so our model architecture combines the best of convolution-based approaches. We use a residual CNN feature extraction, each block incorporation, allowing the model to weight important feature channels. The crucial is our transformer style self-attention modules. These capture long-range dependencies across the spectrum, enabling the model to understand global patterns in wing bit harmonics. Experimental results demonstrate the effectiveness of this approach. We achieved an overall accuracy of 88.73 with the macro FM score of 88.78, indicating balanced performance across all classes. The class-wise analysis revealed fascinating insights. First species class 0 achieved FM score of 84.78 and class 2 88.27. Most remarkable are more except with a F1 score of 90 the curve of 1. This near perfect discrimination of strategies. And talking about the key insights and analysis, so the spectral analysis reads why the model performs so well. So the pollinated shows harmonic overtones and distinct horizontal bandings in the spectrogram, making it easily distinguishable. In contrast, the species exhibit more broad, rapidly decaying spectral energy expressed as alpha. The PCM proves crucial, providing sharper transient and improved harmonic features that are attention mechanism leverage. And impact and application, the real world impact of this technology is
Advi, your
significant.
screen
In
is not
precision
visible.
agriculture, our system enables early pest detection for timely intervention while preserving beneficial pollinators, a crucial balance for sustainable farming. This leads to reduced pesticide use, automated
Nandini,
24/7
hello
Advi,
Nandini.
monitoring,
your
and
screen is not visible.
substantial cost reductions. The deployment scenarios are diverse and practical. We monitoring seamless IoT integration into smartphone and identification. Beyond agriculture, this technology serves as a valuable research tool for entomologists. So our vision is clear: intelligent, auto-driven entomological surveillance systems that reduce reliance on physical traps and manual labor, supporting truly
Advi,
sustainable
your
agriculture.
presentation is not visible.
Our future work and directions. First is robustness, deploying our systems in noisy field environments with varying acoustic conditions. Second, scalability, expanding beyond our current three species, focus to comprehensive insect taxonomies that could cover entire agricultural ecosystem. And third, real-time processing, implementing continuous audio stream analysis for immediate alerts.
Okay, I guess there was some bad internet connection from her end. I hope we can move ahead session chairs, right?
Yes, I think we should move ahead, Anishka.
Yeah, thank you.
Anshika, sorry.
Yeah, thank you so much. Thank you so much for it. So, do we have anybody who has missed their presentations? I guess no. So, I sincerely want to thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope the session was informative enough for all of you. We, on the behalf of the whole team, thank you for your support during this fourth version and all the previous three versions of the conference. We will be happy to have you in the fifth version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days, and the publication will be live within 7 to 8 months. So kindly cooperate with the team of ISBM 2025. Before ending this session, I would like to take a moment to thank our session chair, Professor Adolfo, for chairing this session. Thank you so much, sir. Would you like to share a quick closing remark with us?
Okay, thank you. Um, Wait. um, Of course, I would like to thank those presenters who have presented their papers very interestingly today. And we actually have learned so much, especially on the aspect of artificial intelligence, because this is the new concept, as far as research is concerned, and it is not yet an overused topic, in fact, and thus it makes it very interesting and um, informational. Thank you so much.
Thank you so much, sir. I would also like to take a moment to thank Professor Shafi for chairing this session. So, would you like to share a quick closing remark with us?
Yes, Anshika, the first request from me that change my affiliation.
Oh,
Uh,
sure, sir, sure.
earlier
We'll
it
do
was
that.
right. First of all, I'm thankful to GR Foundation because they are given the opportunity to interact all the people. Uh, the research, if you see, we have came across various presentation from different domain and different localization also. The presentations were from generative AI to bioacoustic injective. One of the presentation was from cosmetic sections also, generative AI also. Basically, it gives an opportunity to us also to learn and to understand the how the things which are current trends and technology is going ahead. I really appreciate all the participants or researchers' efforts for taking time to do the research on current trends and technology, because definitely it helps to make a good society around us. So thank you very much. Thank you all the presenter for sharing their research with us, and I wish good luck to all of them. Special thank you to Anishka. She made our presence comfortable and help us to interact with each other in very smooth way. So thank you, Anshika.
Thank
And once again, all the best to all the participants. Take care. Bye
thank
bye.
This is a token of appreciation to the chair on the behalf of whole team of ISBM 2025 and the Global Knowledge Research Foundations and partners. I would request everyone to kindly turn on their cameras for a quick snapshot before we end the session. Thank you so much, everyone. Thank you so much for the session.
Take care. Bye.
Thank you so
Take
much.
care,
Bye bye.
everyone.
Bye, Ariba.
Bye bye. Take care.
Bye.